Hey guys, this is Miss Sullivan. We're going to start with lesson 1-2. You do need your interactive notebook. You also need some extra paper for your extra practice, and you need your Envision textbook for lesson 1-2, which begins on page 13. However, we will begin on page 15. So the first thing that you need to do is pause the video and add these words to your interactive notebook. These words are repeating decimal, which is a decimal expansion that repeats with the same without end. A terminating decimal is a decimal that ends in 0. A decimal expansion, a number that may terminate or repeat. A rational number, any number that can be written as a fraction. Irrational numbers are any numbers that cannot be written as a fraction. This should say may. So pause the video and add these to your interactive notebook and then begin the video again. I'm going to go ahead and start. Okay, so on page 15 at the top under Try It, what is the decimal form of 100 over 3, 100 over 5, and 100 over 6? Determine whether each decimal repeats or terminates. Okay, you also need your calculator. You are allowed to use your calculator at any time, okay? So our first one is 100 over 3. Okay. Anytime you want to make a fraction, a decimal, you have to divide the numerator by the denominator. So your division would look like this. Okay? And if you plug that into your calculator, you're going to get something like this. 33.33333. That is repeating, okay? I would personally write this as, the correct way is 33.3 with a repeating bar. This is a repeating bar. Okay? If a number repeats, you can do this repeating bar. Okay? So 100 over 3 as a decimal is 33.3 with a repeating bar over the 0.3. Okay. 100 over 5. That would look like 100 divided by 5. You can plug this into your calculator or work it out. We know 5 can go into 10 2 times. 2 times 5 is 10. 10 minus 10 is 0. We have to bring that 0 down. 5 cannot go into 0, so it stops. So 100 divided by 5 is 20. Okay? That terminates. So you're determining whether each decimal repeats or terminates. We know this one repeats. But 100 over 5 terminates. Okay, it stops. It comes to an end. Okay, the last one, 100 over 6. You can plug that into your calculator and you should get 16.666666. But we know that we'll put a repeating bar over that 6. Okay, so this one repeats. So 100 over 3 and 100 over 6 repeat, where 100 over 5 terminates. And that's what you should have in your book under example number 2, Try It, on page 15. Okay, now at the bottom, okay, so under example 3, Try It, on page 15, it says, is negative 0.3 with a repeating bar a rational number? Let me go ahead and say this. Rational numbers repeat or terminate. Okay, that's all you need to know about rational numbers. They repeat or they terminate. So is negative 0.3 with a repeating bar repeating or terminating? Repeating. Therefore, it is rational. Okay? So if we look at the next question, it says, is 3.14, 144, 1444, and 14444, which means it's not terminating, it's going on and on. The next one would probably be 1 with 5 4s after it, a rational number. Okay, you're probably thinking, yes, it's rational because it repeats. In order for it to be rational based on repeating, the same thing has to be repeating. So the same amount of 4s would have to be repeating. Instead, it's adding a 4 every time, okay? So 3.141441444 dot dot dot. That's important, okay? The same thing is not repeating. You're adding a 4 each time. In order for this one to be rational, it would have to be something like 3.1414141414. Plus, this decimal does not stop, okay? It does not terminate. This one is not rational. Okay? Okay, on page 16, under Do You Know How, number 4, says what is the decimal equivalent of each rational number? In other words, what are these fractions in decimal form? So A says 7/20ths. So if you type 7 over 20 or 7 divided by 20 in your calculator, you can get the answer. Also, 20 into 7. So 7 divided by 20. Will 20 go into 7? No. So we have to add a decimal and 0. Will 20 go into 70? Yes. But anytime we add a decimal within our division, we have to add it in our answer. So 20 will go into 70 3 times, giving us 60 with 10 left over. Okay, 20 won't go into 10, so we have to carry down a 0. 20 will go into 100 5 times. That is the same thing you get when you type 7 divided by 20 in your calculator. So 7/20ths is the same thing, is equivalent to 0.35. Okay? If you type in, for B, negative 23 divided by 20, you get negative 115. Okay? So let's make C a decimal. You type in 1 divided by 18. You should notice something. Okay? You should notice that it's 0.05 with ongoing 5s. Therefore, that repeats. That 5 repeats. Make sure you only put the repeating bar over what's repeating. The 0.5 is not repeating. The 5 is repeating. The repeating bar only goes over the 5. Okay, for D, if you type in negative 60 divided by 22, you should also notice something. It's negative 2.72, which repeats. The 7/2 repeats. If it repeats at least 3 times, you count it, okay? So if you type that into your calculator, you see 72 3 times. The repeating bar goes over both the 7 and the 2 because both repeat with each other. Okay? On page 16 under Do You Know How, on number 5. There are 5,280 feet in a mile. What part, keyword, of a mile in decimal form will you drive until you reach the exit? Okay, you have been taught before the part over whole method. That's what you are using here. They even gave you a clue because they said what part of a mile. The mile's the whole. Okay, in decimal form. So let's set that up. The part, the exit, which is here. So the part is 1,000 over the whole, which is 5,280. If you put that into your calculator, you should get 0.1893, and the 93 repeats, so you need a repeating bar over the 93. Page 17, under Practice and Problem Solving. In 6 through 8, write the decimal equivalent for each rational number. Use a bar over any repeating digits. So number 6, 2/3. If you type 2/3, the way it looks into your calculator, so 2 divided by 3, you get 0.666666. So it's 0.6 with a repeating bar. Number 7, if you type 3/11 into your calculator, you get 0.27272727. Therefore, you need a repeating bar over 27. Okay, number 8. This is where it gets a little tricky. I'm pretty sure you've heard of the backwards C method before. In order to put this fraction into our calculator, you need to change it from a mixed number to an improper fraction or to a fraction, okay? So, if we have, let me make this littler, 8 and 4/9, our backwards C says that we multiply 9 and 8 and then add 4. And make sure that you know that's let me make that a clear plus, okay? So 8 times 9 is 72 plus 4 is 76. You always keep the denominator. So 76 over 9. If you add that into your calculator, if you put 76 divided by 9 into your calculator, you get 8.444444. Therefore, this one is 8.4 with a repeating bar over 4. Okay? Number 9 on practice and problem solving on page 17 is 1.0227 with the 27 repeating a rational number. Explain. I told you earlier, any repeating number is rational. So yes. Why? Is because the 2 and 7 both repeat. Okay, number 10. Which should Aaron use to convert a fraction to a decimal? We have been doing this whole PowerPoint. Anytime that we put these into our calculator or we do our division, what do? We divide the numerator by the denominator. So say 3/11. We always divide the numerator by the denominator, or we put it into our calculator as 3 divided by 11. Therefore, we are dividing the numerator by the denominator, which is C. Number 11. Is the fraction 1/3 equivalent to a terminating decimal or a decimal that does not terminate? So in other words, if we make 1/3 a decimal, does it terminate or not? So let's make 1/3 a decimal. You can put that into your calculator. Okay? And you get 0.3333 or 0.3 with a repeating bar, which means the 3 goes on and on and on and on. Therefore, does it terminate? No. So it is make sure you can read that. It is a decimal that does not terminate. Okay, number 12. Determine whether the given number belongs to each set. So let's just look at them set by set. Okay, negative 34. A whole number, integer, or rational number. We know rational numbers stop or repeat. Does 34 stop? Yes. We know integers are whole numbers and their opposites. This is a opposite. Yes. But is it a whole number? No. So negative 34 is an integer and a rational number. Number 13. Ariel incorrectly says that 2 and 5/8 is the same as 2.58. Convert 2 and 5/8 to a decimal. So let's do that first. So 2 and 5/8. This one we use our backwards C. We do 2 times 8 plus 5. So 2 times 8 we know is 16 plus 5 is 21. So 2 and 5/8 as a as a fraction is 21/8. It's an improper fraction, but we can still work with it. So 21 divided by 8 is 2.625, not 2.58. What do you think her error was? It looks like to me she took the 5/8 and just made it a decimal. So she had 2 and 5/8 and she made it 2.58. So she just incorrectly made this a decimal instead of doing it the correct way. Number 14, it says use structure. Consider the rational number 3/11. What are the values of a and b divided by a when you use division to record the decimal form? Okay, well, we know that we always divide the numerator by the denominator. Therefore, our numerator goes inside. So what is our numerator? We know our numerator is 3, and it goes inside. And our denominator is 11, and it goes on outside. So a divided by b, we know our numerator goes in the inside. So b is 3. And our denominator goes on the outside. Therefore, a is 11. What is the decimal form for 3/11? You can use your calculator. And once again, it's the same thing we got earlier. The decimal form is 0.27272727, or 0.27. This is the correct way. Okay? Number 15. At a grocery store, Daniel wants to buy 3 1/5 pounds of ham. What decimal should the digital scale show? Write 3 1/5 as a fraction and then divide. The scale should read blank pounds. So we got 3 1/5. We use our backward C. We do 5 times 3 plus 1. 5 times 3 is 15 plus 1 is 16. So our new fraction is 16/5. Divide that. And you get 3.2. Therefore, the scale should read 3.2. Now we're on page 18. Number 16 says reasoning. At a butcher shop, Hilda bought beef and pork. She left with 18 8/25 pounds of meat. Express the number of pounds of pork she bought using a decimal. So let's make 18 8/25 a decimal first, okay? Okay. So So if we have 18 8/25, we do the backward C. So 18 times 25 is what we're doing first. It's 450 plus 8 is 458. So 458 over 25 is 1832. So at a butcher shop, if Hilda bought beef and pork, she left with 18 8/25 pounds of meat. Express the number of pounds of pork she bought using a decimal. We know beef beef pounds is right here, 8 17/20. So we need to subtract that from the total to see how much pork, okay? So let's make 8 17/20 a decimal. A decimal. So we do 20 times 8. And what do you get? 160 plus 17. And what do you get? 177. So our new fraction is 177 over 20. And we know that that equals, by using our calculator, that 8.85. So the total amount in decimal form is 18.32. The total amount of beef in decimal form is 8.85. So to find the pork, we've got to subtract the total by the beef, and we get the pork. So if you subtract that, okay, 2 minus 5, we cannot do that, so we have to borrow and make the 2 a 12, and we get 7. Can we do 2 minus 8 after we borrow that 1 from the 3? No, so that 2 has to become a 12. We have to borrow 1 from the 8. 12 minus 8 is 4. Can we do 7 minus 8? Nope, so we have to borrow 1, and the 1 makes a 0. 17 minus 8 is 9. So the total amount of pork is 9.47 pounds. Okay, number 17. Is 9.373 a repeating decimal? Is it rational? Explain your reasoning. So is it repeating? Does it repeat? 9.373. It comes to a stop. Stop means terminate. Therefore, it does not repeat. It terminates. Okay? Is it rational? Well, we know rational numbers repeat or terminate. So if it terminates, then yes, it is rational. Number 18. Aiden has one box that is 3 3/11 feet tall and a second box that is 3.27 feet tall. If he stacks the boxes, about how tall will the stack be? Okay, so if he has one box that is 3 3/11, let's go ahead and make that a decimal. Okay. Three times 11 is 33 plus 3 is 36. Okay, so 36 over 11. That is 3.27. The 27 repeats. Okay. So it says that he has a box that is 3 3/11 feet tall and a second box that is 3.27 feet tall. If he stacks the boxes, about how tall will the stack be? This one's easy. You just add the decimals together. Seven plus 7 is 14. 2 plus 2 is 4, plus the 1 that we carried over is 5. 3 plus 3 is 6. So 6.54 feet. Okay. 19. You are adding, no, I'm so sorry, we skipped this. We skipped 19 and 20, okay? The higher order ones, we skipped those. So we skipped 19 and 20. Okay, so we skipped 19 and 20, so on the bottom of page 18 on assessment practice number 21, which of the following shows 117 and 151 200ths as a decimal? It is a bigger number, but we do the same process. We use our backwards C. So if we have 117 and 151 over 200, we use our backwards C. We do 200 times 117 plus 151, okay? So 200 times 117 is 23,400 plus 151 is 23,551 over 200. So our new fraction is 23,551 over 200. So 23,551 divided by 200 is 117.755. So A. Okay, the last one. Use the negative fractions -4/5 and -5/6. Part A. Find the decimal equivalents for each fraction. So -4/5 and -5/6. So it's -4 divided by 5. You get -0.8. -5 divided by 6. You get -0.8 and 3. So it's -0.83 with the 3 repeating. Part B. Which is a repeating decimal? Which digit is repeating? So we know the -0.83 has a repeating 3. So we know that's our repeating decimal, but it's wanting to know which fraction has the repeating decimal. So the fraction that has the repeating decimal is -5/6. Which digit is repeating? That's our 3. Okay, that is the end of lesson 1-2. After you watch this video, if you have any questions about anything or any concepts, please reach out to me. I will help you in any way I can. Thank you for watching.